Sustainable aviation fuel, or SAF, is the most significant tool we have to decarbonize the aviation industry today. Today, we will trace the journey of a single drop of waste cooking oil from a commercial kitchen all the way into the wing of a jet. The primary pathway for this transformation is HEFA, hydroprocessed esters and fatty acids. It all begins in the kitchen. Every year, restaurants and food processors generate thousands of tons of waste cooking oil. Instead of being discarded, this oil is collected and aggregated by specialized waste management firms. This collection network is the first critical link in the SAF supply chain, requiring strict certification to ensure its origin. From local kitchens, the oil moves to regional hubs where it is tested for quality and moisture content before shipping. Once aggregated, road tankers transport the bulk oil to a dedicated HEFA biorefinery. Before the chemical magic can happen, the oil must be thoroughly cleaned of impurities like metals and phosphorus. This involves degumming and bleaching to remove phospholipids and trace minerals that could damage the refinery's catalysts. Finally, the oil passes through guard beds to catch any remaining microscopic contaminants. Now, we enter the core of the HEFA process, hydrodeoxygenation, or HDO. Waste cooking oil is made of triglycerides, long carbon chains held together by oxygen. In the HDO reactor, high-pressure hydrogen is introduced at high temperatures alongside a catalyst. The oxygen is stripped away and released as water and CO2, leaving behind pure, straight-chain paraffinic hydrocarbons. At this stage, we have what is known as sustainable biogenic fuel, specifically renewable diesel, but it's not yet ready for the freezing altitudes of flight. Jet fuel must remain liquid at temperatures as low as -47 degrees. Straight chains would freeze. So, we move to the hydroisomerization stage, where the straight paraffin chains are rearranged into branched chain isomers. This branching lowers the freezing point, ensuring the fuel stays fluid in the coldest flight environments. Simultaneously, selective hydrocracking clips any oversized carbon chains into the ideal range for jet fuel. This precisely controls the molecular weight, focusing on the C8 to C16 range that defines kerosene-based fuel. The final step in the refinery is fractionation, where the different hydrocarbon products are separated. Based on their boiling points, the mixture is separated into naphtha, renewable diesel, and our target, sustainable aviation fuel. Typically, 50 to 70% of the total volume produced in this process is high-quality SAF. Before this fuel can leave the site, it undergoes rigorous quality control testing. Every batch is checked for purity, energy density, and freezing point to ensure it meets international standards. HEFA-produced fuel must comply with ASTM D7566, the global standard for synthetic paraffinic kerosene. A critical rule is blending. Currently, SAF is blended with up to 50% conventional Jet A1 fuel. This is because SAF lacks aromatics found in fossil fuels, which are needed to keep engine seals working correctly. Once blended, however, it is a drop-in fuel, meaning it requires no changes to the aircraft or the engines. Now, the fuel is ready for its final journey, distribution to the airport. Specialized road tankers are filled with the SAF blend, each shipment meticulously tracked for sustainability reporting. These tankers act as the final bridge in the supply chain, connecting the refinery directly to the airport's fuel farm. At the airport, the fuel is stored in high-capacity tanks, ready to be pumped into the aircraft. The final step occurs on the apron, as a refueling team connects the tanker to the aircraft's wing. The waste cooking oil, now transformed into high-performance fuel, flows into the wing tanks. Because the carbon in this fuel was originally captured by the plants used for the cooking oil, the net emissions are drastically reduced. Compared to traditional fossil jet fuel, this pathway can reduce life cycle CO2 emissions by up to 80%. This makes every flight powered by SAF a significant step toward the goal of net zero aviation. While waste cooking oil is a primary feedstock today, the industry is scaling to include many other sustainable sources. Agricultural waste, forest residues, and even municipal solid waste are being integrated into the SAF ecosystem. Biorefineries are expanding worldwide, from Singapore to Rotterdam to California, to meet the surging demand. Government mandates and airline commitments are ensuring that SAF becomes a permanent part of our energy infrastructure. By 2050, the aviation industry aims to achieve net zero carbon emissions, with SAF providing the majority of those savings. This transformation is a feat of engineering, chemistry, and logistics working in perfect harmony. It represents a true circular economy, taking yesterday's waste and using it to power tomorrow's travel. The future of aviation is not just about flying faster, but about flying cleaner and more responsibly. The refineries operating today are just the beginning of a global energy transition in the skies. Understanding this complex supply chain is the first step in supporting the technologies that will keep us flying sustainably. From the kitchen fryer to the airplane wing, the journey of SAF is the journey toward a greener future.